Hey guys, my name is Stevie, and I'm gonna try to explain my understanding of the modular arithmetic concept used in the rock paper scissors lizard Spock game. Now, please correct me if I'm wrong, but I mean this is how I understand it. I'm not entirely sure if it's right, but I just want to put it out there so if I'm wrong, you guys can correct me and stuff, and I can improve on these videos I'm making. Now, the first concept is that we have a circle with 0, 1, 2, 3, and 4. Now, 0 is synonymous to rock, 1 to Spock, 2 to paper, 3 to lizard, and 4 to Spock. Oh, sorry. 4 to scissors. My bad. Scissors. Now, the idea behind the game is that if we choose a certain point, say for scissors, we know scissors wins to lizard and scissors wins over paper. However, scissors loses to rock and scissors loses to Spock. So we can say going clockwise around the circle, the 2 points from the point we picked are always lost to. That is, we lose the 2 points after the point, and we win against the 2 points preceding the point we pick. Now, to understand this, we have 0, 1, 2, 3, 4. This represents 5 points on this wheel. Now we want to understand the modular arithmetic concept behind this point. Now, if we choose 2 certain points on the circle, say 4 and 1, we subtract and we get 3, right? Well, scissors and Spock. We know scissors loses to Spock, so we can actually say, or we can assume 3. The value 3 represents a loss. If we do the same for 4 and 2, we get 2, which is win. You can say value 2 represents a win. If we do the same for 4 and 3, which is scissors and lizard, we know scissors wins, and we have 1, so we can say 1 can be represented as a win. Same goes for all the points in the circle. However, if we get 3 and 4, we get a -1. And now this is where the problem comes in, because -1 does not actually signify a win, because -1 is actually loss. Same goes for 2 and 4. We get a -2, which is a loss. Meaning if we pick 2, if we pick paper and we match it against scissors, we get a -2 value, which paper loses to scissors, so it's a loss. And if we get 1 and 4, we get a -3, which is a win. And same goes for 0 and 4, we get a -4, which is a win. Now we can see these values are actually, how shall I put them? They actually counteract. So we say -1, -2, 3, and 4 are losses, and we say 1, 2, -3, and -4 are wins. Now, to actually make this, more responsible, we can take the modular arithmetic of the what's it called, or the values gotten from picking 2 points on the circle. Now, if we take 1 module 5, we get, if we take the points 4 and 3, modulo 5, we get 1. So 1 modulo 5 is 1. If we take 2 modulo 5, I'm sorry, if we take 2 modulo 5, we get 2. Same thing, 3 modulo 5, we get 3. If we take 4 modulo 5, we get 4. Now, if the number is positive from modular arithmetic, 1 modulo 5 is 1, 2 modulo 5 is 2, 3 modulo 5 is 3, 4 modulo 5 is 4, and 5 modulo 5 is 0. Now, note this 0, it's also 5. 0 is also 5. I'll put 0 there because, convention. Anyways, understanding modular arithmetic. If we take the negative of these numbers, we get -1, -2, -3, -4. Let's say if we take 3 minus 4, we have 3 minus 4 is equal to -1. The modular equivalent of -1 is 4 according to this wheel, and we know 4 is a loss, so we can better represent this as saying, I'm trying to put it in a way that you can understand it. We don't want negative values. If we have all these points, we have 8 points. We have 1, -1, 2, -2, 3, -3, 4, -4. Now we know the positive points. 1 and 2 represent win. 3 and 4 represent losses. However, it's actually it's the inverse of the negative. 1 and 2 represent losses and negative, and -3 and -4 represent wins. Now, the idea of using modular arithmetic is for simplification, meaning that rather than having to program all these points in our if, elif statements, we can just take the modulo of each of them and represent it as just 4 points or 4 statements, excluding the tie statement, or if they choose the same thing, we get a tie. Excluding that statement, we have 4 statements to actually print, which is easier. Now, if we choose -1, right, and if we choose 3 and 4, 3 minus 4 is -1, we have -1. Using the modulo table of -1, -2, -3, -4, the equivalent of -1 for the modular arithmetic is actually 4. And we know 4 is a loss, so we can say -1 is congruent or synonymous to 4, which represents a loss. And this is just the basic concept behind the Python game Rock, Paper, Scissors, Spark. I'm going to use another example. If we choose 2 and 4, paper and scissors, paper loses the scissors, so the answer is -2. Doing the modular of this, we get -3, because according to the table, -2 is synonymous to 3, and we know 3 is a loss, so we can say paper loses the scissors, as in we can represent it in our Python expressions. Same goes for 1 and 4. 1 minus 4 is -3, right? And -3 on the table, on our modular table, is 2, and we know that 2 represents a win. So we can say Spark wins over scissors. And that is the idea behind the modular arithmetic tables, or behind the modular expression in our rock, paper, scissors, lizard, Spark game. I hope this video helped. I'm sorry it's my first video, you know, and it's really hard to actually come off and explain things. I just figured that it's actually tough, and this is just how I understand it. It might not be totally right, but I mean, if it helps you grab some of the concepts behind it, then that's just great. Well, yeah, thank you.